Hello everyone. So welcome to the week 7th of Principles of Signals and Systems. So today we are going to discuss about the question which were taught in the lecture of week 7th on the NPTEL portal. So students are not attending this lecture live, so we will be recording this lecture and we will upload on the YouTube, and the link of YouTube videos will be shared in the NPTEL portal. So you can watch this lecture offline also on the YouTube. And if you have any doubt, then you can ask in the YouTube comment box. Uh, I will reply with the solutions. And even some more doubts are there, then you can ask in the next week lecture, that is on the every Monday 5 to 7 p.m. So today we are going to discuss about the Fourier transform and the question based on Fourier transform. So today's lecture will be mostly on the Fourier transform. We'll see the properties of Fourier transform, and then we will solve lots of questions based on it. So like in the last in the last lecture, we have seen about the Fourier series that can be generalized only for periodic signals, not for aperiodic one. So that is, any periodic signal is represented as linear combination of harmoniously related complex exponentials that we have seen. So the limitation is overcome through Fourier transform, which is applicable for the both periodic and the periodic signals. So the Fourier transform gives the frequency domain description of time domain signal. So just write this point. Fourier transform gives the frequency domain description of time domain signal. And a periodic signal is basically that which is have a period with infinite period. Like all the signals are periodic. Like if the signal is aperiodic, that is also periodic with infinite period. As the period increases, the fundamental frequency decreases, which makes a periodic signal very small or close in frequency. So now we will see the definition of the Fourier transform. So for any signal xt, the Fourier transform of xt can be given as, you can write it as x omega because it gives the frequency domain representation of the signal. And this will be integration over minus infinite to plus infinite xt into e to the power of minus j omega t integration with respect to dt. So the transform x omega is frequency domain description of xt here. And in the right side of the equation is known as Fourier integral, and as xt and x omega makes Fourier transform pair. So we can denote like this. Now for the inverse Fourier transform, uh, this will be the Fourier inverse of x omega. So this will be xt. Okay. So the xt using the inverse Fourier transform, the formula is 1 by 2 pi integration over minus infinite to infinite x omega e to the power j omega t dt. So we can also find signal xt using inverse Fourier transform, and we can find the Fourier transform of any signal xt using these two formula. So this is very very important with respect to any competitive examination. And also like we can substitute in terms of frequency omega is equal to 2 pi f. So these are the simple things. So we will see some of the basic signals. Before that, we will see the condition for existence of Fourier transform. Like first of all, signal xt should be absolutely integrable. This means the integration of xt dt should be some finite amount. So we will write these points, like conditions for existence of Fourier transform. So the first point is signal xt should be absolutely integrable. This means the integration of xt mod of xt dt, that should be less than infinite, and the integration is from minus infinite to plus infinite. Second, signal xt should be deterministic over any finite interval. This means it should have finite number of maxima and minima over a finite interval. So signal xt should have finite number of maxima minima in the finite interval. And it should have finite number of discontinuities, and all the discontinuities should be of finite size. Like wherever it is discontinuous, it should not be infinite. So it should have finite number of finite size discontinuities. So we will take one basic signal and we will see the Fourier transform of it, like the most simplest one. The first we will take as xt is equal to e to the power of minus at ut. So here it is given that a is greater than 0. So we know that e to the power of minus at ut is like this. For negative value of t, it is 0. And from here, it is at t is equal to 0, it will be 1. And after that, as t tends to infinite, the signal will tends to 0. So this is our signal. We have to find the Fourier transform. So we have to just use a simple formula, that is integration over minus infinite to plus infinite e to the power of minus at ut dot e to the power of minus j omega t dt. So here we know ut is there, so this integration will trim from 0 to infinite. e to the power of minus at, e to the power of minus j omega t dt. In the next step, we can write it as e to the power of minus, we'll take common, a plus j omega, and t will become common here. Now this integration is very simple. We know that we can write that this as x omega is equal to minus 1 by a plus j omega e to the power of minus a plus j omega, and the lower and upper limits are 0 and infinite. Here it is given that a is greater than 0. So now this s omega will be when omega is infinite, it will be 0, and then when it is 0, then it will be like 1 of minus 1 by a plus j omega 0 minus 1. So it will be 1 by a plus j omega. So now we will see how we can plot it, the polar plot of this, the magnitude and the phase plot of this x omega, whatever we got. So we got here x omega as 1 by a plus j omega. So the magnitude will be mod of x omega, that is equal to 1 by under root of a square plus omega square, and also it will be the like angle will be angle of x omega, that is equal to minus of tan inverse w by. So now we will try to plot this like so the maximum value of magnitude of x omega will be at omega is equal to 0. This you can do by differentiating also. Differentiate x omega with respect to omega, equate it to 0, and just get the value of omega. At that value, it will be either maxima or minima. So in this case, at omega is equal to 0, the magnitude of x omega will be 1 by under root of a square, that is 1 by a. And this plot will be something like this in the positive side, and in negative side also it will be like this. When omega tends to minus infinite, it will be 0. When omega tends to infinite, then also it will be 0. And at this value, it will be 1 by a. And this is the omega axis, and this is the magnitude of x omega. So this is the magnitude plot. And now we can also do the phase plot here. So the maximum value of phase, it will go up to pi by 2 to minus pi by 2. Like when omega tends to infinite, it will be minus pi by 2. And when omega tends to minus infinite, it will be minus of minus pi by 2, that is equal to pi by 2. So it will be like omega, this is angle of x omega. So the plot will be like this. It will be from minus pi by 2 to pi by 2. And for omega tends to infinite, it will be minus pi by 2. And for omega tends to minus infinite, it will be pi by 2. So we'll take some another question. Let's take this time one signal, that is the second example we will take. Xt is equal to e to the power of minus a mod t. So in this case, first we will find the Fourier transform, and we have to find the Fourier transform, and also we have to like plot the magnitude and the phase spectrum of this signal. So first we'll use the basic formula, but before that we will see what is this signal xt here. So let's plot it on the time axis. So when it is t is equal to 0, it will be 1, and it will go like this. for positive value of t, and for negative value of t also it will come like this, and this will be 1 at t is equal to 0. So this is our signal. Now we will find the Fourier transform of it by using the simple formula minus infinite to infinite e to the power of minus a mod t e to the power minus j omega t dt. Now for value of negative value of t, this mod t will come out as minus t, and for positive value of t, this mod t will come as only t. Okay, because the mod t will always be a positive term. So now we'll break this integration in two parts, minus infinite to 0 e to the power, here minus t will come out for negative value of t, so minus minus will become plus, so at e to the power of minus j omega t dt plus 0 to infinite e to the power of minus at e to the power of minus j omega t dt. So here we will get x omega is equal to, now this is the simple integration what we have seen in the previous case also. So like this one we have seen, that is 1 by a plus j omega, and for this when you do you will get 1 by a minus j omega, just like in the last case however we have done, in the same way we have to do, we'll get the answer. So our x omega will be 1 by a minus j omega plus 1 by a plus j omega. This will be a square minus of j square will be minus 1 plus omega square. J omega will get cancelled, it will become 2a. So the Fourier transform of e to the power of minus a t ut, this will become 2a by a square plus omega square. So for this also, if you draw the magnitude plot, we will get, like simply we can do the magnitude and phase plot for all these things. The maximum value at omega. If you don't know what is at the maximum value, just differentiate this x omega with respect to omega and equate it to 0. That will be the point of maxima or minima. Just basic mathematics you can use. So now we will see some other properties and some other basic signals. So before moving on to that, we'll first see the most basic signal, that is a delta signal. Like when xt is given as del t, then what will be the Fourier transform of this? So x omega is the Fourier transform of xt. So this can be written as minus infinite to infinite. Xt is here del t into e to the power of minus j omega t dt. So this integration converges to 1. We have already studied about this. So the Fourier transform of del t is 1. Okay. So here you can see in time domain the del t is represented as in frequency domain it is represented as like this. It is a constant value 1 for all value of the omega. So this was one of the basic signals. Now we'll take some other examples. We can take signum function. or we can take the rectangular function also. That is very important as uh, with respect to the gate point of view. Like in most of the gate question depends on this. So the rectangular function can be given as, we can plot like this. So this is our time axis here for all value of minus t by 2 it will become 0, and here from minus t by 2 to t by 2 or tau by 2 it will become 1. So this is our rectangular function. So xt here we can write it as xt is equal to rectangular function of t by tau. Like tau is the width of this rectangular function. So now we have to find the Fourier transform. So Fourier transform of xt, that is given as, simply we will use our formula, that is minus infinite to infinite. This function is xt is our rectangular function, e to the power minus j omega t dt. Now we will see for different interval how we can break this integration. So before minus t by 2 this is 0, and after t by 2 it is 0. So we don't have to integrate over that interval. So for only minus tau by 2 to 0, this will become 1 into e to the power of minus j omega t, and for 0 to tau by t also it is 1 only, so we can completely write here from minus tau by t, tau by 2 to tau by 2, that is equal to e to the power of minus j omega t. So now we will get minus 1 by j omega e to the power of minus j omega t here, plus tau by 2 minus tau by 2. So x omega is equal to minus 1 by j omega e to the power of minus j omega. First we will put tau by 2, then minus of e to the power minus j omega minus tau by 2, that will become plus j omega tau by 2. So this complete thing, this will become like this divided by, here you do j, okay, we know that this will become minus 1 by omega minus of 2 sine omega tau by 2. So this minus minus will become plus. So finally our x omega is equal to 2 sine omega tau by 2 divided by omega. And now like at omega is equal to 0, omega cannot be equal to 0, and the value of x omega, if we have to find at omega is equal to 0, we have to use L'Hospital rule simply. So simply we can see here that the Fourier transform of rectangular function, if it is given as rectangular tau by t by tau, that can be written as tau into sinc of omega tau by 2. So this is just the width of the rectangular pulse, and after that this will be half of the width of rectangular pulse, and this will be like how this is 1 by tau. This 1 by tau will come here, 1 by 1 by tau, so tau will come in plus. We will solve number of questions, then you will directly remember this formula. But for shortcut, you can remember, or also you can, whenever you face difficulty, you can directly use the formula and expand it. It won't take more than half minute also, because very simple. Just we have to use this Fourier transform formula. So now if you plot this signal like t sync Like here we will draw the first our rectangular pulse, that is from minus tau by 2 to plus tau by 2, 0, and the magnitude is 1. Now the Fourier transform of this will become, we know that sinc function is oscillating function and it decrease like this, and here the magnitude will be, this will be tau, and the point where this value is 0 will be pi tau by 2, and again every time it will be multiple of this 2 pi tau by 2, and then 3 pi tau by 2, like that, minus pi tau by. So this is the way to find the Fourier transform of the rectangular pulse. Next we will see the signum function, how to find the Fourier transform of signum function. So let's suppose xt is given as signum of t. First we will see what is signum of t. So when it is given xt is equal to signum of t, this is equal to 1 for all the positive value of t. This is equal to 0 for t is equal to 0, and minus 1 for t is less than 0. So the function will look like this. This will be minus 1, 1, and here this is the time axis. And this is our xt. So now if we have to first find the Fourier transform, what we will do, we can do one manipulation here. Like as we have seen that we know that this is our e to the power of minus 80 ut. Okay, and so this signal is e to the power of minus 80 ut, we have already seen, and here it will be minus of e to the power 80 u of minus t. Okay, so what we will do, when you substitute here a tends to 0, then this become flat and it will become signum function. So we can write signum function as, this is the approximation of signum function, xt is equal to signum of t, that is approximately equal to limit a tends to 0 e of minus 80 ut minus e of 80 u of minus t. So in this way we can write our signum function. Now we will take Fourier transform on both the sides. So take Fourier transform on both the sides. What we will get? We will get Fourier transform of xt is x omega, and we have already done the Fourier transform of e to the power minus 80 ut. That is, here limits a tends to 0, that we will substitute at the end. It will be a plus j omega minus 1 by a minus j omega, and when you substitute a tends to 0, you will get, first we will simplify it. Here a square plus omega square minus 2 of j omega minus 2 of j omega divided by omega square. So this, and when you multiply with j in denominator and numerator, we will get 2 by j omega. So The Fourier transform of signum of t is equal to 2 by j omega. So what will be the magnitude and phase response of this? So here we can write magnitude of x omega will be 2 by omega, and phase of x omega, that is equal to minus pi by 2 when omega is greater than 0, and pi by 2 when omega is less than 0. So these are some of the basic signals we have seen, and we have to see for now. We can see for unit step function. So using this only, like using the Fourier transform signum t, that with that only we will approximate ut in terms of signum t, and we will find the uh, frequency, like Fourier transform of this unit step function. So the next example, let's take find the Fourier transform of ut, that is unit step function. So here we can write ut is equal to 1 plus c. Our signum function was like this. Now how we can make it as a ut? So first of all, we will add 1 into this. So when you do 1 plus signum of t, that will become from 0, and this will become 2. Now we will divide it by 2. So after dividing it by 2, this will become again 1, and 0 by 2 is 0 itself. So, so 1 plus signum t by 2, that is equal to unit step function. So this is our ut. Okay. So ut is equal to 1 plus signum of t divided by 2. So now take Fourier transform on both the sides. So we will get Fourier transform of half plus signum of t by 2. That is equal to half into Fourier transform of 1 plus half into Fourier transform of signum of t. The Fourier transform of signum of t is 2 by j omega. So that will be, and for Fourier transform of 1 is like 2 pi del omega. So this will be 1 by 2 into 2 pi del omega plus half into 2 by j omega. So we will get pi del omega plus 1 by j omega. So the Fourier transform of ut will be pi of del omega plus 1 by j omega. Okay. So this is also one of the important one. Just remember this basic Fourier transform, so that in examination, if complex problem comes, you need not to waste time on this basic Fourier transform. No need to calculate this. Just remember these are very simple. For signum of t, just you remember signum of t, ut you can directly derive. No need to remember everything. Just remember whatever is important. So now we will see some of the inverse Fourier transform of some of the important signal. And we have seen till now the Fourier transform of important signal. Now find inverse Fourier transform of x omega is equal to del omega. Just wait for a minute, I will drink water. So in this question, we have to find the inverse Fourier transform of x omega is equal to del omega. So we'll simply use the formula, that is xt is equal to 1 by 2 pi from minus infinite to plus infinite. Like this function is del omega, that is x omega into e to the power of j omega t d omega. This is the only formula I have written. Here I know that I have done one mistake, that's why I'm correcting it. Here it will be d omega. Because this x is in terms of omega, so we have to integrate in terms of omega, and then only we'll get in terms of time t. So now after this integration, we will get as this del omega is valid only at omega is equal to 0. So this will become 1 by 2 omega e to the power of j omega t, and omega is equal to 0. So it will become 1 by 2 pi. And simply this integration will become 1. So directly we can write this as 1 by 2 pi. So the inverse Fourier transform of del omega is 1 by 2 pi. So when you multiply with 2 pi, you can get like this also. The Fourier transform of 1 is 2 pi del omega. So this is also important. Just remember this. These are for some basic signals. So now take the second signal. Another question. Here x omega is equal to del of omega minus omega naught. Now if we have to find the inverse Fourier transform of this is equal to 1 by 2 pi integration over minus infinite to plus infinite del of omega minus omega naught into e to the power of j omega t dt. Okay, so here we can write it as 1 by 2 pi. Again, this will be written at omega is equal to omega naught. So e to the power of j omega t, omega is equal to omega naught. So our answer will be e to the power of j of omega naught t. So the inverse Fourier transform of this signal is 1 by 2 pi e to the power of j omega naught t. And also the Fourier transform of this signal, when you take it will be 2 pi del of omega minus omega naught. Okay. So these are simple signal. Now we will see for cosine and sine. So I will solve for cosine. You can solve for sine signal as a homework. So let's take another question. Find the Fourier transform of xt is equal to cos of omega naught t. Second, xt is equal to sine of omega naught t. So first what we will do, we already know that for exponential, complex exponential function, we have like Fourier transform and inverse Fourier transform. So we'll break this signal into that form. So first we'll write xt is equal to cos of omega naught t. That is, we can write it as e to the power of j omega t plus e to the power of minus j omega naught t by 2. So now we'll take Fourier transform on both the sides. So we have already seen here e to the power of j omega naught t. The Fourier transform of this is 2 pi del of omega minus omega naught. This will become 1 by 2. This will become 1 by 2 e to the power of j omega naught t. That will become 2 pi del of omega minus omega naught plus 2 pi del of omega plus omega naught. So our x omega, that is equal to, here 2 and 2 will get cancelled, pi of del omega minus omega naught plus pi of del omega plus omega naught. So in the frequency domain, it will have two component at omega is equal to omega naught and at omega is equal to minus of omega naught. So here we can write the Fourier transform of cos omega naught t is pi of del omega minus omega naught plus pi of del omega plus omega naught. So this will have only uh, like a when you draw this spectrum, we will get at what value this will exist at minus omega naught and at plus omega naught. When it is plus omega naught, the value will be pi. When minus omega naught, then also value will be pi. For all other value of omega, this will become 0 because del omega only exists at omega is equal to 0. So del omega minus omega naught will exist only at omega is equal to omega naught. Okay. So this is one part. And the second part also, like sine omega naught t, that also we can solve now. So the second part is xt is equal to sine of omega naught t. So for this, we can write sine of omega naught t as e to the power of j omega naught t minus e to the power minus j omega naught t divided by 2j because 2j will come in denominator so that j and j will get cancelled. So now take the Fourier transform both the side, we'll get x omega and here 1 by 2j. This will be 2 pi del of omega minus omega naught minus 2 pi del of omega plus omega naught. We have already seen how it will come. Then it will become pi by j del of omega minus omega naught minus del of omega plus omega. So the Fourier transform of sine omega naught t will become pi by j del of omega minus omega naught minus pi by j del of omega plus omega naught. So when you draw the frequency spectrum of this, like the sine omega naught t consists of two impulses. So the first is at omega naught and second is at minus of omega naught. And what will be the value? That will be pi by j. And here it will be minus of pi by j. Okay. Here you can see minus of pi by j. So therefore the Fourier spectrum of this sine omega naught t consists of only two components of frequency, that is at omega naught and at minus of omega naught. So any doubt up to here, then you can ask. Now we will see some of the properties. Like we will write all the properties like time reversal, duality, linearity, time shifting, everything. So this we have to finish it. Properties of Fourier transform. The first one is linearity. Then the Fourier transform of alpha x1t plus beta x2t will become alpha x1 omega plus beta of x2 omega. Okay. The next is time shifting. So in this, if the Fourier transform of xt is x omega, then Fourier transform of x of t minus t naught will be e to the power of minus j omega t naught x omega. We can also prove this. Just take the simple formula of Fourier transform and do, you will get the answer. So now we will take one very good example. Like we'll solve using shortcut because this kind of question, if you solve using like formula and all, it will consume lots of time, and even in examination you can do some silly mistakes and you will result in the wrong answer. So let's take a question. This is a gate question. Determine the Fourier transform so the signal is given as, so this is our signal, and we have to determine the Fourier transform of this. So we'll use the previously we have found, for that only we'll use like we'll first simplify this. This xt is equal to x1t plus, so when you do this x1t, like xt is equal to x1t plus x2t, will get the signal xt. You can see here, from minus 2 to 1 it will be 1, and from minus 1 to 1 it will be 1 plus 1, that is equal to 2. So we can write xt as rectangular function of t by, the duration is 2 here, plus rectangular function of t by duration is 4 here. Okay. Now uh, the Fourier transform of this becomes like this term 1 by 1 by 2 of sinc, this rectangular, the Fourier transform rectangular will be sinc of duration, that is 2 into f. Here f is frequency. Okay. For this it will become 1 by 1 by 4 of sinc of duration is 4 into f. F is frequency here. So sorry, x omega is equal to 2 of sink of 2f plus 4 of sink of 4f. Now, this can be written as uh, 2 pi f is equal to omega. So, f is equal to omega by 2 pi. 2 of sink omega by 2f is equal to omega by pi plus 4 sink 4f is equal to 2 omega by pi. Now we can write as 2 of sink omega pi is equal to sine omega by pi, or we can leave this solution up to here only, or we can simplify it further also. So this is the Fourier transform of this signal x over xt. Okay, so this was one of the question. Now we will see one question on transfer function. So this is our equation given yt is equal to 0.5 x of t minus td plus capital T plus x of t minus td plus 0.5 into x of. So in this question it is asking the filter transfer. This was also a gate question. Transfer function that is h omega of such system is given by. So basically we have to first write the input output relation equation, and after that just we have to do the Fourier transform on both the sides. We will get y omega in terms of x omega. Then we have to divide y omega by x omega. That will be our h omega. So we'll proceed in the same way. Here first our output input equation is 0.5. Okay. So now we'll take Fourier transform on both the sides. So we'll get y omega is equal to 0.5 into e to the power j omega into minus of td plus t, and this will be x omega. So we'll take commonly x omega outside, and this will become e to the power of here it is minus of j omega, td is only there, and again we'll get plus 0.5 of e to the power of j omega minus of td minus capital T. and x omega. So now what we will do? We will do y omega by x omega. This is only our h omega. So this will become, you can see that minus j omega td, minus j omega td and minus j omega td are common in all the three terms. So we will take e to the power of minus j omega td outside as a common. So we'll get 0.5 into e to the power of j omega capital T plus 1 plus here 0.5 into e to the power of minus j omega t. Now we can write this as e to the power minus j omega td is 0.5 is 1 by 2 like this, and this term we know that this is, what is this? This is our cos of omega t. Okay, so here we can write it as h omega, that is equal to it will become 2 of cos omega t, then 2 will get cancelled, it will become cos omega t. H omega is equal to e to the power of minus j omega td cos of omega t plus 1. So this is the transfer function of this system. Okay. So now we will see. I will directly write a few more properties and then we'll solve one or two questions on that. So the next is frequency shifting. First I will write all the formula. So this will be just like a short notes also for you guys, because I am discussing all the concepts in very short way. So the Fourier transform of xt is, let's suppose x omega. So the Fourier transform of e to the xt into the power j omega naught t will be x of omega minus omega naught. So this you can prove simply using just the Fourier transform formula. Next is time scaling. These all are also taught in the classroom, like NPTEL lecture, weekly lecture. If Fourier transform of xt is x omega, then Fourier transform of xat will be 1 by mod of a x of omega by a. Okay. So we'll not go into the proof. I think proof is already done in the classroom. So we'll just see the properties and solve some questions. The next is time reversal. So the Fourier transform of x of minus t will be x of minus omega. And one more we'll see duality in this. The Fourier transform of then Fourier transform of x of t means, like when you are substituting here omega is equal to t, this will become 2 pi small x of minus omega. Understood? When you substitute here omega is equal to t, then this will become here 2 pi into here minus omega and 2 pi additional multiplication. So this is the duality property. So we'll see. There are so many other properties also that is taught in the classroom, but we'll see some of the question. So the next question. This is a gate question. Four option was there. So the Fourier transform of e to the power of minus pi t square is given as e to the power of minus pi f square. So now then the Fourier transform of e to the power of minus alpha t square, what it will become? So we can write as e to the power minus alpha t square as e to the power minus pi under root alpha by pi t square. So this will become t square, pi will get cancelled, alpha t square. Okay. So this we can simply write. So now we'll see the properties what we have studied till now. So if Fourier transform of xt is given as x of omega, and we know that Fourier transform of x of at is given as 1 by a mod a x of omega by a. Okay. So here e to the power of minus pi under root alpha by pi t square is what will be this? Here you can see that this e to the power minus pi t square and this. So here t is changed as under root of alpha by pi into t. So this is our a. Okay. So this will become 1 by mod a. So 1 by under root of alpha by pi x of omega by a. So e to the power of minus pi f square by a. What is our a here? That is equal to, here it is like to see minus pi t square. So a is root under alpha into pi ka square. So this will be alpha by pi. So a is equal to here alpha by pi. So here also we have to write alpha by pi, and here also alpha by pi. So finally we will get like magnitude will be here under root. So it will be under root of pi by alpha e to the power of minus, this pi will go up, it will become pi squared f squared by alpha. So the Fourier transform of e to the power of minus pi, sorry, alpha t squared, that is equal to under root of pi by a e to the power minus pi squared f squared by alpha. So which option is correct? Under root of pi by a e to the power of minus pi squared f squared by alpha. So option B is the correct option. So if you have any doubt in this question or before any question, you can ask, or you can ask in the YouTube comment box also. So today we'll close the lecture here only. So tomorrow, next time again, we'll meet on the next Monday, that is 5 to 7. Thank you everyone.